Okay, our goal is to find the derivative of g of x in this case. We have a couple different options we could go with. The first option, and I'll run through both of these for you. The first option I would do is just multiply this out. All right, it's small enough. We should be able to go first, outer, inner, last, and multiply this out. So as we multiply our first together, we get 4x cubed multiplied by x. So in that place, we could put 4x to the fourth. Next, we have outer, so 4x cubed times 3. That's going to make plus 12x cubed. Inner, negative 11 times x is negative 11x. And finally, lastly, we have negative 11 times positive 3 is going to be negative 33. So I'm making an effort just to rewrite my original. I haven't actually taken a derivative yet. I would probably go ahead and combine these like terms in the... Oh, I don't have any like terms. Never mind. I'm not going to combine any like terms. Instead, now that we've rewritten it in an expanded form here, let's go ahead and take the derivative. So find g prime of x. So power rule, one term at a time. So first, 4x to the fourth, we're going to bring the exponent down in front and multiply by the 4 that's the coefficient. So we get 16. And then x to the 4 minus 1 makes 3 for our new exponent. Plus, again, power rule for that second term, bring the exponent down in front, multiply by the 12. So 3 times 12 makes 36. Reduce the exponent by 1. So 3 minus 1 makes 2. Next term we have is a linear term. So a linear term is just going to be the coefficient, the number out in front, as the derivative of x is just 1. And then finally, that's a plus 0 at the end. We could definitely leave off that plus 0 to give that as our best answer possible. All right, that's one alternative you have, is multiply it out. And that's probably the easiest way to get through this one. The other alternative is, I know that the original function is called g, but treat this as something different. I'm going to treat this as, I'm writing out my formula. G in my formula is going to be x plus 3. I realize the original function name's g, but let's kind of ignore that for right now. We could use the product rule because we can treat this as two things multiplied together. The product rule would be f times g prime, and I am referring to the f and g up above my individual sets of parentheses there, plus f prime times g. So as we set this up and try to find the derivative, first thing I'd do is copy down f. All right, that first set of parentheses, 4x cubed minus 11. Multiply that by g prime. So I want to take the derivative of x plus 3. So that's just going to be 1. Plus, next we take the derivative of the first set of parentheses. So power rule here, we get 12x squared plus 0, the derivative of negative 11, times g, we copy down the second set of parentheses. All right, so that is a valid derivative as well, the derivative of the original function. Don't confuse the g and the g over here. I'm just using the standard way we tend to write the product rule, with f and g being the two things multiplied together. All right, hope that makes sense. If we did multiply that all out, combine our like terms, we're going to get back to the exact same answer as what's written in the black right there, the 16x cubed plus 36x squared minus 11. Hope this helps.